here. This is one of my favorite slides just to really get a start on, because no matter what organization or industry you come from, you are in the software business. And that's what this slide is really trying to illustrate. If we take, for instance, the car really has become a rolling computer, a computer on wheels. Whether it is a combustion engine or an electric engine, it is still largely a computer that happens to be mobile. Likewise, when we look at GE and their business, their entire business and the supply chain and the delivery chain, the production and everything else that they do is almost entirely operated by software. And without software, they would no longer be in business. But my favorite example is the Starbucks example. Starbucks you think of as a place that delivers coffee and perhaps other foods and a nice place to sit and relax with free Wi-Fi. And yet, Starbucks is essentially a software company. They are a company that depends on software to deliver over-the-air updates to all of their equipment. And so they push this out from centralized development organizations in order to make it possible for their baristas and the other people who work for Starbucks to offer their newest and latest and greatest products without having to go through lots of training, without having to retool, without having to essentially take up a lot of capital investment. They can do this almost entirely through software. Now, the software industry has changed in some significant ways. And what we see here is really just a picture that you may be familiar with in your organization. If you're doing Agile, this is going to look fairly familiar to you. Here we have what may be a developer or a product owner or some other business person who is starting to add stickies to a wall in order to try and work on a product. And in the Agile world, we are now trying to be much more flexible, much more adaptable, much faster in order to do our work. And so Agile has really been an important part of the story of software change over the last 20 years or so. And in fact, what we see when we look at some of the statistics is, and this is actually now a year old, but it says that 77% of all organizations report using Agile at some level. And this is not necessarily pure Agile. It's not necessarily Scrum or a strong Kanban or a lean approach, but it is an acknowledgement that the very basic ideas that flow behind Agile are critically important for the success of the organization. And so what we see is that Agile has had a very significant adoption throughout the software industry. Likewise, and this is equally important, is the adoption of Git. Git is a distributed version control system. It is a replacement for SVN or CVS before it, or some of the myriad other version control systems that have been out there. But Git brings the idea of distribution such that each developer can work within their own sandbox and know that, be confident that any change they make is isolated into their sandbox and it does not block somebody else from being able to do their work in their sandbox environment. And this, as we will see, becomes incredibly important for improving the quality and the velocity of delivering new features. So together, Agile and Git have been transformative in how we do software development. And yet, even though we've transformed our development organization over on that left side to be Agile, we have left operations and we have left customer service behind, and we have these silos that have developed in which there's a lot of cross purposes, perhaps there's finger pointing. Certainly there are differences in objectives. Developers, by their nature, are interested in pushing new code, new functionality, new value out to their customer as quickly as possible. And often developers are less concerned with operational concerns such as stability and reliability and security and all those kinds of things that operations finds to be critical. Operations is interested in making sure that whatever they operate actually runs and doesn't come down because there was a bug, because it was deployed on the wrong operating system, because there was insufficient resources, and so on. Operations is in the business of keeping things going. So development is interested in pushing out new things. Operations is interested in making sure that whatever they get actually runs. And customer service, which we don't talk about nearly enough, customer service is there trying to hold back the irate customers who have now found that the software that they depended on is no longer functioning because developers sent out a new release that operations put up and turns out it doesn't work, and customer service needs to know how to support this new release. And so what we find are silos are developing in ways that prevent these different organizations from being able to work together in order to support our business. If our business, as I said a few slides ago, is about software, then we had better make sure that these three groups work together. So let's take a step back for a moment and ask ourselves whether or not any of these are indicative or describe our organizations. So the first one that we're looking at is whether or not we have SLAs, and if we do, are those SLAs effective? So many of our clients do not even have an SLA set up because they either can't measure the SLA, they have no way of knowing whether or not the SLA was actually met, so there's no point in having an SLA if you can't actually measure it, or equally important, they know out of the gate that they will not meet customer expectations. And so therefore they are hesitant or unwilling to publish an SLA, knowing that any SLA that would be acceptable to their customer is not actually achievable. So we want to get to the position where we can not only measure SLAs, but we know that we can meet or exceed the customer expectation. Our second question, and this really gets to the heart of operations, is that operations is always hair on fire, fixing that Sev1 problem because nobody told them that this newest library that we're pushing out requires a patch to the database, or requires a patch to the operating system, or requires additional resources that they hadn't counted on in their environment. Perhaps they have been asked to upgrade and nobody did a security check. And they are now always in the situation where they need to figure out how to fix a problem as opposed to being able to get ahead of it and advise development on those things that are actually going to work and are going to be stable in their environment. And what that does in turn is it causes friction between your development and your operations teams. Your operations teams become very risk averse. They are not interested in deploying new software until it has been thoroughly tested, until they are absolutely confident it will run in their operations environment. And yet development has the delivery dates that have been set by the business in order to roll out new capabilities to the customers, whether they're internal or external. Development is constantly trying to meet dates that have been set by the business, and operations always seems to be the big break on letting them meet those dates. We want to get rid of that friction. We want development and operations to work together. We want them to be seen as part of the same team pulling towards the same goals. And so our last question is, are we making our dates? Is development actually able to deploy software that operates correctly and confidently but within the dates that have been set and to which they have agreed with management? And so this then, if you are seeing within your organization that some or all of these are symptoms that you recognize, then you need to be thinking about DevOps. You need to be thinking about how do I move simply beyond an agile development team to a DevOps-oriented organization. And so that's where we want to say Agile is great, Agile is essential, but Agile isn't enough. Agile is only the starting point that helps you to change the culture of development, but it doesn't address the end-to-end team that is required in order for your business to operate successfully. So what goes beyond Agile? No great surprise. We're going to tell you that it's DevOps. We're going to tell you that DevOps is a culture, and that DevOps is based upon certain processes that help that culture to be implemented successfully in your organization. And finally, we're going to talk about some of the tools that it takes you to get there. But what we want to see from a DevOps organization is that you are building reliable software that is delivered much more quickly with much less risk to your customers with less cost to you. Those are some of the promises, and I'm going to show you some statistics in a few minutes that I hope will convince you that this is not simply marketing fluff, but this is actual, real functioning capability. This is a promise you can realize. So let's first of all define what are we talking about when we talk about DevOps. What do we mean? Now we're going to give away Gene Kim's book called The Phoenix Project. And DevOps is the approach that I'm going to talk about is really defined by Gene Kim in that book. But it is based on earlier work by Eliyahu Goldratt, who came out in 1984 with a book called The Goal. And the goal focused on physical manufacturing. What is a product line in a physical manufacturing, and how do you address the issues associated with that? And that's what Eliyahu Goldratt looked at. And Gene Kim came along and said, you know, we can apply these same principles in software. And let's talk about what do we mean by that. Well, what we mean is a rule of three. And the first rule is what we call left to right thinking or workflow. And again, this really is very much a product line. It's an assembly line. It's something that any of us who have been in software, which I've been in for 30 years or more, we've been doing this. We can do this in our sleep. We know that we start with requirements, we do development tests, we operate, and then we have to support what we've built. And that is very much a waterfall kind of thinking. We go from step to step to step. And Gene doesn't suggest in any way that we can bypass these steps. We need requirements. We need to do development and so on. We can't not do these things. And so what we want to look at, again, following on Eliyahu Goldratt's idea of the theory of constraints, is we want to look and say, where are our bottlenecks? Perhaps we've got a bottleneck between development and test. Or perhaps we've got a bottleneck between test and operations. Again, my experience in development is that developers, if we have a 3-month lead or cycle time, we will take the first 2 months and 3.5 weeks to do our development, and then we'll give it to test and wonder why test can't seem to actually do the testing in the 3 days that we've left available to them. And likewise, test will push back, and they will say to operations, I need an extra 3 weeks, and by the way, that means I'm going to eat into the time you had available to operate. And operations is going to say, yeah, and by the way, it's going to take me 6 months to acquire the additional hardware that I need in order to operate all this stuff that you've been giving me. And so now what we've done is we said there are bottlenecks that we need to somehow address. And the theory of constraints says focus on the bottleneck that's the worst, figure out what it takes to address that bottleneck, and then once you've addressed that bottleneck, move to the next one. We're going to talk about those kinds of things as we go through the rest of the presentation. The second way, or the second rule, is the right to left, which is how do we amplify the feedback that is coming into our group and make sure that everybody is aware of it as quickly as possible, and that we can swarm on the incidents that actually occur. So when test finds a problem, they don't sit on it for a week before they notify development that there is a problem that needs to be fixed. That when a customer calls in, or 20 customers all call in with the same problem, that we are swarming to fix the incident, and that we are also quickly addressing the root cause problem that underlies it. So we want the feedback that's whatever the rightmost place is where it came in, whether it came in support or operations or tests, we want that to flow all the way back to the left as quickly as we can, with as much information as we can, so that it can be addressed as quickly and reliably as possible. And so that's what we call the right to left thinking, amplifying that feedback and making it visible to absolutely everybody who could possibly have something to do with fixing it. And then the last rule is this iteration that we know from Agile, where we are continuously trying to improve. We are not simply saying, well, it worked great this time, so we have nothing more to learn. Rather, we are always asking ourselves, what can we do even better than we did it the last time? Where is the newest constraint? What is the thing that is blocking us from being even faster and even more successful in the next iteration that we go through? So those are our rule of three. We want to go from left to right, and we want that to move as quickly as possible. We want to go from right to left and get that information out in as completely and fully and transparently as we possibly can. And we want to continuously experiment and learn. We want to get better. One of my favorite quotes comes from Werner Vogels, who's the Amazon CTO, and what he had said is, if you build it, you run it. And what do we mean by this? What we really mean is, in a DevOps world, we are in this together. And when development and operations comes together to develop and run the software, they have much greater accountability, there's much greater transparency, there's much faster movement to fix it. And so what you find at Amazon, and you find this at Atlassian as well, is that the team, the DevOps team that builds a particular release, is then the team that has to operate and support that release. So developers are not simply, I'm off to the next release. Don't, call me if in the morning if there's a problem. The developers actually may sit for the first 2 weeks on the customer support, the help desk, taking in incidents for this new release, because who is in a better position to quickly fix the problem or diagnose the misunderstanding than the people who actually wrote it? And so this becomes the DevOps approach of how we build transparency and accountability for what it is we're actually deploying. Okay, so let's talk some statistics that I hope will convince you that DevOps is something that you really want to pursue, that the high-performing DevOps teams really do achieve spectacular results when they actually focus on doing DevOps. That's what I want to convince you of on this slide. So let's go ahead and look at some statistics. Now, these come from the State of DevOps report. You'll see that on the lower left-hand side. This is the 2017 report. I haven't seen the 2018 report, which won't come out until next year. But this is what Puppet has come out with, and I think you'll find some of these to be extremely impressive. So let's start with the first one. We can see a 5-time lower change failure rate when we use a DevOps approach for our development. Now, what do we mean by this? What we mean is you are 5 times less likely to break something when you deploy that release, whether that release consists of 6 months worth of work or it consists of 2 hours where a developer put together a quick patch for a problem, you are 5 times less likely for that change to actually result in some kind of failure. So we are not suggesting you don't go through good, strong, standardized change management. On the contrary, you do go through change management, but you're going to go through it with much greater confidence that what you're going to deploy actually will work and will not harm the stability of what's already running. My second statistic for you is that when there is a problem, whether it hits your production environment, you are 96 times faster to recover from that failure. Now, that doesn't necessarily mean you're 96 times faster to deliver the fix, but you now know that you will be able to recover from that, whether it means rolling out the change that caused the problem, or it means being able to implement a workaround, or actually deliver a fix for that problem. You are 96 times faster actually addressing that. And what that means to your customers is you may be able to fix problems that you find in production before they even notice that they're there. And when they do notice that they're there, they're going to be much less unhappy with you because they're going to get those fixes faster and more reliably. In addition, when we're talking about new features, we are saying that you will find that a new feature is 440 times shorter lead time from the initial request to the time it gets deployed. Now, that doesn't mean you have to deploy that much faster, but it means that if your business person comes and says, I've got a revenue generating opportunity and all I need is a small change, you don't have to tell that person, well, our next release is 3 or 6 months down the road. It is possible, and in fact, large organizations like Amazon are doing this every day. They are rolling out small changes with hours of actual lead time. From the time it's requested, the time it's deployed, it may be no more than 1 or 2 hours in length, and that is with quality, with stability, with change management. It is not shortcutting those standard processes, but what it's saying is I don't have to wait for my 3-month or 6-month release to get out a feature that could start generating revenue for me today. So what does some of this mean? Well, you may be able to deploy 46 times more frequently. And what I'm showing you in these statistics are not what are actual results that Puppet has measured. They are showing that the top DevOps teams are deploying 46 times more frequently than the lower end DevOps teams. These are teams that are actually able to put into production 46 times more code, more features, more revenue generating capabilities than what those teams at the bottom are doing. And that's what these statistics show. And this is not promise. This is reality that's actually happening in the industry today. So let's just ask ourselves this following question. If we can deploy so much faster, and if our unplanned time goes down so significantly because our engineers are deploying code that works and therefore they're not spending unplanned time fixing things that didn't work, let's say they have 10% more engineering time. What does that mean for a development organization that now has 10% more time to actually spend on something other than fixing problems? Well, the first thing we can see is that we're going to be able to experiment more. We're going to put out new features much faster. We're going to be able to do that with more confidence and fewer bugs. So we are now going to be able to address the revenue generating capabilities of our organization much faster. We're going to be able to invest in future quality, and really the better way of thinking about this is we're going to retire technical debt. If you are a developer, you know that technical debt is a way of life. It is part of the process. But if I've got 10% more time, I've got time now to actually spend paying down that technical debt that I had to build in, and it was a necessity to build it in so that I could get my feature out fast, and then I can come back, pay down that technical debt, and make sure I'm not letting it start to eat me up. So I can invest in my future quality of the software. And finally, and really most importantly, if you've got 10% more development time, that's your competitive edge. That's your ability to bring the features and products to market faster. That's your ability to meet your business needs. And that ultimately, at the end of the day, is what we are all here to do. As I said at the very beginning, we are all, no matter what our industry is, whatever our company does, we are all a software company. And our job is to deliver software that enables revenue generation and cost avoidance to our business. And we can do that, and I think I've sort of tried to show that DevOps is a way to do it that has been proven. This is not marketing fluff. It really does work. So if I have convinced you, and I hope I have, that DevOps is something that you should care about, that your company should want to adopt, or to adopt in a much more successful way, then let's talk about how do you get there. We're going to talk about 3 pillars of getting to DevOps: culture, practices, and tools. Let's get started with culture. So the culture is really the most important thing here, and I can't emphasize enough that you will not succeed with DevOps if you think of it only as a set of processes and tools that you are going to simply write up, make everybody follow, and you will magically have a DevOps organization. That simply will fail if you are not starting by looking at your culture. And the first thing you need to look at is the culture of collaboration. Let's look at these 4 pieces. The first one, and possibly the most important one, is the idea of a shared responsibility. You need a place where you need your organization from the top to the bottom to say, we are in this together. There is no individual blame. We don't play that kind of game anymore in a DevOps organization. In a DevOps organization, each member of the team is saying, how can I do my job better? And what are some of the things that would help the rest of the team do their job better? And in almost every instance, we're looking not at individuals, people, as the root of problems. We are sharing the responsibility, and we are saying, how can we as a team grow and improve? And so that gets us to the next piece. How do I build that empathy and that understanding across my teams? How do I get my developers to understand the pressure that operations is under? How do I get my customer service folks to understand the constraints and the limitations that developers are operating under, are developing under? How do I get everybody to understand that we are all in this together, and that each of us has a set of constraints and limitations and objectives that may not always match? One of the ways I do this is I cross-pollinate my teams. I create teams that are not simply developers or simply operations. I actually put a team together that is cross-functional, from the requirements to development to testing to operations to support. I want a team that is capable of doing everything from beginning to end. And when they work together, they start to understand the impact that decisions that they make have on the other members of their team. Equally important, we need to encourage transparency of information. We need to make sure that we are in no time holding information back that somebody needs. Rather, let's have a culture where people have access to all the information they may need, and then they just simply pull it from wherever that repository is when they need it. So that I don't determine whether you need to know something, you determine whether you need to know something, and it's available to you when you need to know it. And then finally, we need effective communication. We need people to talk to each other. We spend far too much time trying to write up contracts, requirements documents that get signed off, test plans that have to get signed off, and when are we spending the time talking to each other about what we're trying to accomplish and the best ways to do that. We need effective communication. The second piece we'll talk about are practices. We've really talked about Agile already. Agile is critically important. You will not get to DevOps without an Agile mindset and approach. We talked a little bit about distributed version control, and that's really Git, and that's the ability to let my developers work independently of each other so that they can make those changes, do their experimentation without stepping on each other's code base. And the last one we haven't touched on is continuous integration and continuous deployment. This is the idea that we want to automate every place we possibly can. We do not want developers and testers and operations folks having to manually build, manually test, and manually deploy when we can have software that will do that for us. So the things that software can do, we want software to do for us. We want the things that take creativity, that take thought, that take planning. Those are the things we want people to be spending their time on. So let's get into the tools. And this is where I'm going to start to look at Atlassian, but let's talk about the DevOps cycle to begin with. We've got, in the upper left-hand quadrant, we've got planning. So we need to plan for what we're going to do. And then following around, we're going to build our software. We're going to use tools to do continuous integration, continuous deployment, and we're going to then deploy someplace out to make it available. We're going to operate. That means keeping what we've deployed actually going. And then we're going to have a feedback loop that tells us what should we do differently, what should we do better, where can we make improvements. And that's our cycle. And DevOps wants us to move through that cycle as quickly as we possibly can. We want that cycle just to flow with as little bottleneck, with as little constraint as possible. And circling around that is real-time communication. Everybody in every part of this cycle needs to be able to talk to each other and do it in real time so that we are constantly communicating with each other. Okay. How does Atlassian fit into this? Well, Atlassian fits in with several products we're going to talk about, and I'm going to give you a quick idea of how they fit. We start with planning, which is Confluence, which is a wiki on steroids. Think of it as a place where you're going to keep all your requirements, you're going to keep all of your discussion about those requirements, your wireframes, and all the documentation that goes into building your software is going to sit within that Confluence environment. And you're going to have discussions about it, and Confluence can handle all of that for you. In addition, you've got Jira Software, which is the project management piece of your Agile environment, which is going to allow you to start to plan how much time will it take, which features can I build within a certain time frame, and so on. So that's where Confluence and Jira Software come together. The second piece you're going to do is you're going to build. And Bitbucket, which is a front end to Git, which makes Git incredibly powerful because it allows you to do things in a GUI that you can't do easily or at all in Git, like embed comments at the file and even at the line level within your code. It handles very nicely things like peer code reviews as well as pull requests if you're familiar with Git. And Jira Software is all part of that, and as I'll show you, because it's managing what's being built. Your continuous integration is Bamboo. Bamboo is that system that will take your plan and it will build your software. It can operate the build systems. It can call the test systems. It can call the deployment systems and give real-time feedback back to Jira and Bitbucket as to whether the software built, tested, and deployed correctly. In your deployment, you've got Bamboo and Jira Software. Jira Software is the thing that's going to help to control the release. What features should I release? And Bamboo is where it's going to actually do the deployment. In operations, you've got Jira Service Desk. Jira Service Desk fits on top of the Jira core. It's very much integrated with Jira Software, and it's your help desk, and it gives you lots of beautiful help desk capabilities. Confluence, again, shows up in the operations because that's where you're going to put your knowledge base, whether it's your internal knowledge base for your help desk agents or a public-facing knowledge base where your customers can start to do self-resolution, and you can start to reduce the number of tickets that actually get opened in your service desk. And then finally, status page, which is a cloud-based location where you can post system issues for your customers so that they are aware of what is happening with the software. So if you've got an outage, well, we'll see this in a moment, and you'll see a little bit of how that all fits in. Okay, so we've gone and talked through the Jira or the Atlassian pieces of it, but as you can see, Atlassian is an open interface, and it has APIs that hook up to just about everything, and we can now have all of these other systems, whether it's a Microsoft Office with docs, with Word and Excel documents, or it's a Splunk at the operations side, and so on, all of which can plug in and play with the Atlassian tools. So DevOps is not an Atlassian concept. I just wanted to point out to you here that Atlassian really covers and is dedicated to covering the full DevOps cycle. Okay, so let's go ahead and talk a little bit about how Atlassian does this, and this will give you a better sense of why DevOps is so powerful and how Atlassian enables it. So this is a little story that we've got built around how DevOps is enabled in using some of the Atlassian tools. So we start with the idea, I didn't mention HipChat, but HipChat is the instant messaging platform that can hook up to lots of different inputs as well. It can hook to Jira, it can hook to Splunk, it can hook to PagerDuty, and so on. So you could have automated messages. And what's going to happen here is that we're going to get an automated message that Sam, who's our operations engineer, is going to see in his HipChat room. And this is going to come from Bitbucket Datadog, which is looking at this, and it's triggering an incident. This comes into HipChat. Now, this is nice because HipChat now has a record of that this happened. It's not going to get lost in an email, and it's not going to get lost simply on a pager or in some queue. It's actually a real-time notification that Sam's going to see. So Sam knows that there's a problem, and in this particular problem, there is a problem that the website has become degraded. The performance is degraded, and Sam needs to know something about it. So Sam is going to log this into Service Desk. This becomes an issue that Service Desk is aware of. And as you can see, we've got the performance on cluster node 2. That's our problem. And that's the incident that Sam has logged. Now, what's going to happen with that? Well, Service Desk will automatically send an alert through HipChat on a mobile device, could be, to Sally, who's our developer, to say, hey, Sally, there's a problem with this node. I need some help to fix it, and it has to be fixed soon, quickly. So what Sally's going to do is Sally's going to get a bunch of developers together, and they're going to swarm this issue, and they're going to use HipChat for real-time communication about this issue, because they may be home, they may be remote, they may be located in other places, but HipChat's going to bring them all together and give them that communications channel. Now they're going to do two things. They're going to open up an incident on status page. Status page is something their customers can see, and they're going to say, we know there's a problem. We are aware of this problem. And the beauty of status page and making this available to your customers is you start to train them that when there is an issue, when they can't get to the web page, or it's degraded, or they can't get to the email server, the first place they do is they come to their status page and they see, there's already an incident, no reason to go to the help desk and raise yet another one. And they can subscribe to this. They can get email updates about this. Status page gives lots of capabilities to keep your customers aware of what is actually happening with your systems. The second thing they're going to do is they're going to look in Confluence. In our Confluence knowledge base, we have been told that the way to address a degraded system is to add another node. So very simple. They know if maybe I have all the steps I need to do there. Sam says, okay, I know what to do. So I go ahead and I add a node. Now Sally says, this has happened 4 times. We really need to fix this problem. There's clearly an issue that we should be doing. So we're going to add an issue into the backlog. We're going to add something to Jira Software, and we're going to link it because the two systems are integrated to Jira Service Desk. So Jira Service Desk incident is now linked to a backlog item in Jira Software. And here's our backlog item. It's TIS 67, and Sally has determined we need to fix this caching issue that we've got that's causing degraded performance. Finally, what does our team do? Our team in our DevOps way is thinking about what can we do better, and they're going to ask themselves in a postmortem, what should we change? And they're going to use Confluence as the place to keep this. Confluence has a nice template that helps to walk you through a postmortem or a retrospective. What did we do well? What could we have done better? Take actions, keep track, and make everybody accountable. Okay, now we're going to move to development. We're going to do this very quickly. Jennifer is going to see that, hey, there's something in the backlog. We're going to put it into Sprint 6. We see at the very top of in progress TIS 67. And Jennifer's going to go, okay, I'm going to work on this, and I'm going to create a branch. Now, I'm doing this right in Jira, but that branch is actually a Git branch that's going to come from Bitbucket. So in Bitbucket, I have now created a branch. Its name picks up the name of the ticket in Jira. Jennifer now works on it. Jennifer asks for a code review from Kevin. Kevin says, I reviewed the code and I've merged it into the main trunk, and now it is merged in. As you can see on the right-hand side, there was a build done against this, and there's a Jira issue linked to it. So now Bitbucket automatically calls Bamboo and says, we had some code that was checked in. Please go out and build it and test it. And so here we have Bamboo executing the build plan to go ahead and actually deploy or build out this code to make sure that it all builds correctly. And finally, Bamboo circles back to Jira Software, and Jira Software automatically shows that we had 2 branches, 8 commits, 2 pull requests, and 4 builds, all against this particular issue. So we know by the check mark at the bottom that the last build at least was successful, and now this particular code branch is building correctly. John, who is our release manager, says, you know what, I think I want to push this out. And even though this is part of a bigger release, John can see that this was actually completed and can say to Bamboo, by pushing just some buttons in Jira, go ahead and deploy this particular branch or the whole release, whatever John thinks is appropriate. So that takes us through our DevOps. We have gotten an incident, we've fixed the incident, we've built and tested the incident, we're operating against the fix against it. We have moved very quickly through our DevOps cycle. So what are we saying that you can do? Well, you're going to get more builds because you're using automated tools that are going to make it possible for you to build every time you check out code and every time you check it back in, running those tests. You're going to see much greater reliability because you have built automation into your development environment. Because of that, you're going to have much greater velocity in deploying these changes. You're going to be able to quickly take one branch of code that has revenue potential or it has cost avoidance, and you're going to get it out to your customer faster. You're going to have greater confidence because you've automated the building, the testing, and the deployment. And because we're using Git, we have much greater independence. We know that when as a developer, we work on a piece of code, we know we're working on a piece of code that will not affect what somebody else is working on. And that when we build it and we test it, we know with confidence that it's going to actually run in the deployed environment. Okay, I've talked very fast. I've got to about 50 minutes worth, and I think we're just about done. We talked about culture. And that is really critical. If you come away with one idea, it is that culture is the base of successful DevOps. We talked about speed, the fact that automation is going to allow you to release faster. It's going to be able to release with greater confidence. We've talked about the idea of fast feedback loops, that at every point along the way, you're going to be learning and you're going to be much faster to fix the problems that do inevitably come up. And you're going to reduce your unplanned work, and you're going to have clear prioritization of what's the most important and what should people be working on. Now, my last slide, and I put this in as a little bit of a plug, but if you are intrigued and if you're thinking to yourself, yeah, this makes sense to me, but how am I going to convince the rest of my team? How do I convince those managers, perhaps, that this is something that really deserves our attention and some investment and some real thinking about how do we get our organization towards DevOps? We can bring in for you to your organization a half-day simulation of what does a DevOps organization look like. And this is not a lecture, it's not a webinar, it's not a bunch of slides. It is a true get off your seat, on your feet, working together simulation of what it means to be in a DevOps environment. And we've done this for many, many different organizations. And what they see is eye-opening, because from when they start to when they end, they see incredible progression of capability just within the time frame of a half day or a 6-hour session. And if you are interested, RightStar can provide this to you at your location. It supports between 16 and 24 people at a time, and I can guarantee you that if you've got skeptics about DevOps, they will get their eyes opened as a result of this simulation. So with that, here is how to contact us. We are very interested in talking to you further about what you might be interested in, how DevOps can really bring value to your organization or to any of the Atlassian tools, which are the ones that I support. Be very happy to speak with you about those tools and how they can be implemented in your organization quickly in order to bring value to you.